Hi, this is Mrs. Marita. Welcome to section 4.3, Solving Systems of Equations by Elimination.
Hello everyone, we'll be on page 84 here, and we're going to be talking about 3 examples here. We're going to start with example 1. Okay, example 1 is a try question that says solve a system of equations by adding. Okay, so it says to solve each system of equations, and so here in question A we have a system of equations where we have two here. And what I notice is that there's a negative 4y and a positive 4y right here. So what I'm going to do is I'm going to draw a big plus sign here on the left, and I'm going to go ahead and add the equations up together. So 2x plus negative x, that gives you just x. And then a negative 4y plus a 4y, that's going to cancel each other out. And that's going to be equal to 5 here. So thankfully, this equation is easy in the sense that the y's cancel each other out, the x's add up to be x, and it is equal to 5. But we know that when we're solving a system, it's not just x equals an answer, we have to find y as well. Okay? So what I'm going to do is I'm going to substitute x equals 5 into either equation. Okay? So I'm going to take this one and use that one to solve from there. Okay, so it's going to be negative x plus 4y is equal to 3. I plug that in. That's negative 5 plus 4y equals 3. Add the 5 to both sides. 4y is equal to 8. Divide by 4 on both sides. Y is equal to 2. Okay, so I have my x value and my y value. That's 5, 2 as my answer. And so there you go. 5, 2 should be your answer, and that's how we solve the system of equations by adding. Okay? And then the same goes for the question underneath it. Okay? So if you go to question B here, it looks like if I just add these two equations up, the x's are going to cancel each other out. All right? And which is nice. So we go ahead and add them up. 2x plus negative 2x, that's going to cancel each other out. And then you're going to be left with 5y is equal to negative 5. 1 plus negative 6 is negative 5. We're going to isolate y by dividing 5 on both sides. Y is equal to negative 1. And so the same goes for here. We're going to substitute y equals negative 1 into either equation. Okay, so I'm going to go ahead and choose the one that has 2x plus 3y equals 1. I'm going to go ahead and put 2x plus 3 times negative 1 equals 1. And then it's going to be 2x minus 3 equals 1. Add 3 to both sides. That becomes 2x is equal to 4. Divide 2 on both sides. X is equal to 2. So the answer is going to be 2, negative 1 here. Don't forget that it's the x is 2 and the y is negative 1 here. 2, negative 1. So as we move forward, okay, in example 2, okay, it says now understand equivalent systems of equations. Solve each system of equations. Now, in the first 2 examples here, they were very easily set up where I could just add them up and it would eliminate a variable, right? But here in question A, if I add them up automatically, a variable doesn't disappear. So what I'm going to do is I'm going to multiply this top one by negative 2. And the reason being is I am going to eliminate x. Okay? So I'm going to write that note here. I'm going to eliminate x as a variable. Okay? So if I do that, I'm going to go ahead and distribute negative 2 into each term. That's going to be negative 2x. Plus, oh, I'm sorry, that's going to be minus 4y. Okay, so it's going to be minus 4y equals negative 8. And then I'm going to bring this one and bring it down here. 2x minus 5y is equal to negative 1. So then from there, I'm going to now add the 2 equations up like I did in the previous question up top. Negative 2x plus 2x, that's going to cancel out the x's. And then you're going to get negative 9y is equal to negative 9. Divide both sides by negative 9. Y is equal to 1, positive 1. And then it becomes the same question that we did up top. We're going to substitute y equals 1 back into the equation. Okay, so I get x plus 2y equals 4. X plus 2 times 1 equals 4. X plus 2 equals 4. Subtract 2 on both sides. X is equal to 2. So 2 comma 1 is your answer here for example 2. So the same goes for the letter question right underneath it. Okay, 2x plus y equals 2. X minus 2y equals negative 5. It's your choice. You can try to eliminate the y or you can try to eliminate the x. Whichever one you got to do, you have to do the opposite, right? So if I'm trying to get rid of this x, I need to make that a negative 2x. If I'm trying to get rid of this y, then I need to make, since this is negative, I need to make this a positive 2y. And that's what I'm going to choose to do. I'm going to make that y a positive 2y. So I'm going to multiply everything by 2. And what you end up getting is 4x plus 2y equals 4. And underneath that, that's going to be x minus 2y equals negative 5. Okay? And in that way, now if I add the two equations up, I can get rid of the y's here. Okay? So these get rid of each other. 4x plus 5x is 5x equals negative 1. And then you divide both sides by 5. X is equal to negative 1 over 5. So it looks like there's going to be a fraction in the answers here. But we're not going to panic. Okay, we're going to go ahead and do x minus 2y equals negative 5. We're going to plug that answer in. Negative 1 over 5 minus 2y equals negative 5. So what we're doing is we're going to try to solve for y here, isolate y. But I don't like the fraction here, so I'm going to multiply the whole thing by 5, okay, to try to get rid of fractions. Okay, so this times this, that's going to be negative 1 minus 10y equals, and make sure you multiply the 5 by everything, negative 25. Add 1 to both sides. That's negative 10y is equal to negative 24. Divide both sides by negative 10. Y is equal to 24 over 10, which can be simplified to be 12 over 5. So your answer is negative 1 over 5, comma, 12 over 5. And there's your answer to that question. For B, it involves fractions, so make sure you take a look and you're able to see this is your answer here. Okay? If you need to pause that and go back and relook at that, go ahead and feel free to do so. Okay? So, we talked about eliminating a variable now. So we talked about addition, solving systems by addition. Now this one is by elimination. And then now in example 4, you're going to choose which method you want to use to best solve the question, right? So it says, what is the solution of each system equation? Explain your choice of solution method, all right? The biggest thing is you got to be able to find the solution, okay? So for in this question, I have 6x here and a 3x, 12y and a negative 2y, okay? I'm going to eliminate x here. Okay, so the way that I'm going to eliminate x is, since this is 6x, I need to make this a negative 6x. So let's go ahead and multiply everything by negative 2. Distribute, distribute, distribute. So what you end up getting is 6x plus 12y equals negative 6. And underneath that, I'm going to need negative 6x plus 4y equals, and then now that's going to be a positive 54. So in this way, after I make that 6x and the negative 6x, I'm going to go ahead and add the two equations together. The x's eliminate each other. That's 16y is equal to 48. Divide by 16 on both sides. Y is equal to 3. If y is equal to 3, then you can plug that back in and solve for x. All right, so I'm going to substitute y equals 3 into 3x minus 2y equals negative 27. So let's plug that in. 3x minus 2 times 3 equals negative 27. 3x minus 6 equals negative 27. Add 6 to both sides. 3x is equal to negative 21. Divide by 3, x is equal to negative 7. So that's negative 7 comma 3 as your answer. Now, if you chose to eliminate y here, you're still going to end up with the same answer. So regardless of which variable you eliminate, the answer solution should be the same, negative 7 comma 3.
Surprise! Now you get Miss Marita for the last example. So just to review, we did the elimination method for this first example where we can multiply the bottom equation by negative 2 and eliminate the x variables. So the elimination method was a great method for example 4, part A. Let's look at part B now. Now for part B, you could use the elimination method here. We would just need to rearrange that bottom equation. Or we can use our substitution method. So for this example, part B, we're going to use our substitution method. The bottom equation has the x variable isolated, so we can substitute 6 minus y into the first equation for x. So just like in 4.2, we're going to take this 6 minus y expression and plug it in for x. So we get 3 times 6 minus y, there's my substitution, minus 2y is equal to 38. And then we'll distribute, and we get 18 minus 3y minus 2y is equal to 38. Combine like terms. On the left, we get 18 minus 5y is equal to 38. And now we'll isolate our y. Subtract 18 from both sides, and we get negative 5y is equal to positive 20. Divide both sides by negative 5, and we get y is equal to, negative 5. We're dividing both sides by negative 5, so we get y is equal to negative 4. And then we'll go back to our x equation, where x is equal to 6 minus y, and plug in the negative 4 for y. So x is equal to 6 minus negative 4. Be careful with that double negative there. And we get x is equal to 6 minus negative 4, so plus 4, and x is 10. So our final answer here, our x is 10 and our y is negative 4. So we've learned 3 different methods for solving systems of equations. See if I can fit this on the page. There we go. And so in our first section, 4.1, solving our systems of equations by graphing. Then in 4.2, we learned our substitution method. And in 4.3, our elimination method. All of the methods will give you the same answer, but we want to select the method that's best for that situation. If both of our equations are in slope-intercept form, maybe we'll just graph them and see where they intersect. If one of your variables, like number 4 part B, is already isolated, then we can use our substitution method. But if neither of your variables are isolated, then the elimination method will be a great strategy. That's it for 4.3. Make sure you copy down all your notes and bring your questions to class.